Hi everyone, I'm Gabriele Venturato from DTI Lab at K11. In our work, we want to solve dynamic decision problems, also known as Markov decision processes. For example, this one, where the robot Wally has to move into the environment, maximizing the utility. So try to avoid the trash, which gives a negative reward, and collect the plants that give a positive reward. In these problems, the transition function is probabilistic, which means it's taking into account the uncertainty of the real world. So finding a good representation for the problem is fundamental, and we wanted to find one for online planning, which means the reasoning engine must be able to find the best action, then the agent has to execute it, and therefore move into a new state, and then the new state is given back in input to the reasoning engine, and the process repeats. Now, these type of problems are not new, of course, but we propose a new representation for reasoning in this setting. We called our new representation dynamic decision circuits. In fact, in literature, there are circuits dealing with either the dynamic or the decision settings, but not both at the same time. And our work aims at filling that gap. So, to do so, we compile the input problem into a circuit representing the transition from one time step to the next one. And we use that circuit over time to perform first a look ahead into the future to label the circuit, and then evaluate it bottom-up, performing a maximization operation to actually make decisions. And the main advantage of this approach is that we do the hard task of compiling the problem into a circuit only once at the beginning, and then reuse the same circuit at each time step with an evaluation which is linear in the size of the circuit. Now, this was just a high-level description of our work, but if you want more details, please come check out the poster. You just have to search for the one with Wally. Thanks.